Double replacement reaction. All right, so what we're going to do is we're going to try to gain a better understanding of double replacement reactions and to become aware that reactions go to completion when one of the products is removed. So there's a bunch of double replacement reactions taking place, and what we're going to do with this lab, let me see if I can angle this down just a little bit more so you can see me. What we're going to do with this lab is we're going to take a whole bunch of chemicals and we're going to kind of mix things up. And then we're going to see exactly which ones take reactions. I think that one of the confusing parts about this lab is basically just keeping track of the 96 well reaction bin, or what do they call it? The 96 well reaction plate. All right. So this is A, and A goes all the way across. And then this is B and C and D and E and F and G and all the way down to, is it H? Yeah, it finishes at H. And then you have columns 1, 2, 3, 4, 5. So what we're going to do is we're going to put one chemical that goes all the way across, and then one chemical that goes all the way across, and one chemical that goes all the way across, and one chemical that goes all the way across. Then we're going to take another chemical and go this way down, a different one here, a different one here, and a different one here. And so we're going to have this grid of 16 different types of mixtures, and we're going to see which one of these actually undergoes a double replacement reaction. Again, when I say something like A1, think of it like the old school game of Battleship. A1 is row A, column 1. That would be this thing right here. Whereas B1 would be row B, column 1. Okay, so first thing they want is calcium nitrate. That's this guy right here. And they want to go A1 through A4, put 3 drops of each. So 1, 2, 3, 1, 2, 3 of the same thing, and 1, 2, 3, and all the way to A4, right? 1, 2, 3. Okay. Now we're going to use copper nitrate in the next one. We're going to go across B1 through B4. So 3 each. This is a blue solution. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay. Now I apologize for this in your example video, but I've ran out of lead nitrate. So I'm going to use iron nitrate and see if that does anything different with the experiment. But you would use lead nitrate. But then again, I'm just showing you how it's done. So we got C1, so it's 1, 2, 3, 1, 2, and 3. You don't need to hear me counting to 3. Okay, and zinc nitrate for the bottom one. So, well, D1 through D4 is going to have zinc nitrate, and it's going to go across. So I'm going to go 1, 2, and 3, 1, 2, and 3, 2, 3, 1, 2, 3. All right. Now, what we want to do is we want to go vertical now. So, in the first well, we're going to put potassium iodide. That is this clear solution. Now I'm going to go 3 drops in each. Yep, 3 drops. So I'm going to go A1, 1, 2, 3. B1 is 1, 2, 3. Oh, C1 is 1, 2, 3. And D1 is 1, 2, and 3. Now, to be honest with you, I noticed, and I'm going to show it to you right now. Maybe you can, no, you can't really see it this way. Let me see if you can see underneath it. Okay. All right, so check this out. See B1 and B2 and B3 and B4? That's the B row is the blue stuff. It's the copper nitrate. But when I put in B row B into when I put in the potassium iodide in there, you can immediately tell that it changed from blue to a different color. Now that means a reaction took place. And that's all you need to do. If you see a precipitate or some kind of reaction or change of color, that's when you know a reaction has taken place. All right, so I did my potassium iodide, and you'll probably want to observe that after whether a reaction has taken place. But it's also sometimes good to, I just notice that reaction takes place, boom, immediately as I see it happen, as I see this thing go inside of the tube. And so I can write that down maybe. Yes, a reaction has taken place. All right, the next one is potassium hydroxide. So we're going to go that in column number 2. 3 each. I'm going to start with A2. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. You get good at dropping these things inside. All right. Then I want potassium oxalate, or sodium oxalate, sorry. That would be what, the Na2O, Na2C2O4. So it's 1, 2, 3. 1, 2, 3. 1, 3. I don't know why I feel the need to like tell you or count in front of you, but and the last one is sodium sulfate. Good old Na2SO4. And we're going to go 3 drops in column 4. Now, what you're going to want to do is you can take, you know, actually before I added, I'm just thinking, they didn't say this in the procedure, and I'm just kind of thinking out loud, this might have been a good idea, is I should have probably taken a picture before I added in the potassium iodide and the potassium hydroxide and the sodium oxalate and the sodium sulfate. And the reason being is because I kind of want to be able to compare what it looked like before and after, because now I'm taking a picture of it, or now I take a look at it and I'm thinking, I don't know if it's completely changed because I don't remember the exact tint of color that it was before. So at this point, what you'll probably want to do is your reactions have taken place. I don't think you'll need to use this to steer anything in there. And then what you'll want to do is, let's see, a chemical reaction is indicated if there's a change of color or a precipitate, a fine solid, is formed. Record these changes in the table provided. What you want to do is you want to observe this, write things down, and then clean it. What I would recommend that you do is take a camera or whatnot and take a picture of this thing from the top and maybe put some white paper underneath here and then take a picture from the top. And that way you'll have this as a good record for you to be able to go back to. What you don't want to do is say, all right, well, I'm done with my experiment, and then I'm going to go off and go play some video games. I'll come and clean it up later. The reason for that is because some of these, if it forms a precipitate, I'm not saying it would, but I'm just saying maybe it might. If it does form a precipitate, what's going to happen is this thing might solidify in there, and then it's going to be really hard to clean. Now, the most important part of this experiment is to do the cleanup. So what you're going to want to do is you'll be able to dump this into the sink. Normally, again, we don't dump chemicals into the drains, but since this is in such a small diluted concentration, we're not going to be killing anything or hurting anything. So I'm just going to dump, and I'm going to use lots and lots of water to kind of, there we go, just kind of get it a whole bunch of times. Dry it off a little bit. And then what I like to do is I like to take my distilled water and spray it in here. And that way I know that I can use this next time. Because if I use just regular water, what's might happen is there might be some kind of residue from the different things inside of the pipes or the calcium or whatnot that will get inside of here. So if I use distilled water, that will basically kill everything and take care of it. So you need to make sure to answer the questions. Then you'll need to write up a full lab experiment, and that one's that one. Make sure you do a good cleanup job and write me up a really good lab report. Aloha.